So again, this just kind of goes over all the rules, plug it in, what happens if you get these things, and there is a place for them to practice. Notice that all these problems are unit circle problems. They have to know the unit circle. It's a great place to review that. There is a unit circle filled out in the pre-cal folder of this particular section of the Dropbox. And then, once we do that, then this is a graphical proof, if you will, of the special trig limits. So instead of actually going through and doing, you can do a squeeze theorem, and that works, and that's what a lot of books do. I chose to do a graphical. It's faster, and they believe you, and once they get the pattern down, it's really easy to use. So here is a worksheet that actually goes through and gives them the graph. So if they don't have graphing calculators all at this time, you can still do this exercise. But if they do have graphing calculators, it's a good time to practice. And so it tries to get them to see the pattern. And so they should come up with all the patterns and be able to work these problems afterwards, which they will see. And so the big pattern is that anytime, notice that the 4/1, and let me go back. So in this, it says, hey, look, there's a hole in the graph, because if you actually trace over, notice that at x equals 0, there's not anything there, which means there's a hole. Well, we know that when we get 0 to 0, that normally means there's a hole in the graph, and there is in this case. And so we have to keep looking, because there's a hole there, but it looks like it's approaching something from both sides. So then we encourage the kids to look for patterns, and at 0 it's 4, and at 0 it's 2, and at 0 it's 3, and at 0 it's like a half. And so can you look at the coefficients of the x's and figure out the pattern? So yes, you can, and if you did, you would notice that it is just a over b. And then, let's look at cosine and see if it works. So when you put in 0, notice you get 1 over 0. That's a vertical asymptote, not a hole. So we know that that's not going to exist, so that's not going to work. And will it work for this? And it will. And the answer to this is 5 over 3, and they'll figure out that pattern. So there are a few that it works for. And so let's go look at that notes page. Let me find it. I have it down here. I do. So on the notes page that I keep referring to, there are all of the situations that work. And even if you flip them or you put them over each other, they all work. Here's that other little weird guy. And I think that's in that worksheet somewhere, but I don't think I actually proved it. I think we just talked about it. It did give them a picture of it. And it said, hey, look, there's 0, 0. That means there's a hole. Let's look at the picture. And it is actually both sides are going to 0. So I didn't prove it by using a squeeze theorem. I didn't prove it by any kind of really hard method. It's just like, let's look at the graph. It's a graphical approach to something, then they will have to use over and over again and have to recognize that. There's some little tips about splitting things up first before they do it in order to find those. And then just wanted to point out that it does say special trig limits to know, and so those are the ones they need to know.